Did you know that the U.S. typical home now has, on average, at least 25 electronic products? 99% of which must be plugged in or recharged. Just in the U.S. alone, there are thousands of utility plants across the country. With more than 300 million people in the U.S. alone, it takes all sorts of energy sources to meet those demands, such as wind, hydro, nuclear, and coal. So you ever thought about how does the energy get from those large power stations and actually then into your home reliably, safely, happens every time? When electricity leaves a power generation plant, its voltage is increased at a step-up substation. Next, the energy travels along a transmission line, those large power lines, to an area where the power is needed. That would be into your neighborhood. Once there, the voltage is decreased or stepped down at another substation, and those are those generally big green boxes in your neighborhoods. Finally, a distribution power line carries the electricity through telephone poles, you've seen those in your neighborhood, and carries the electricity until it actually reaches your home and business. So while power may start at a generation plant at maybe 425 kV or voltage, it actually ends up in your outlet at 110 volts or kV. While we take this all for granted, actually a lot can go wrong, and the distribution system is vulnerable to disruption. We may get annoyed when there's a power outage after a storm, but there can be much more serious consequences like this. Now let's take a look at how Cargill Industrial Specialties and their partners help minimize these risks.
Hi, we're at Eaton's Cooper Power Systems outside of Waukesha, Wisconsin, one of the leading transformer manufacturers in the United States. Cargill has been a partner with Eaton's Cooper for over a decade, where we co-developed the FR3 dielectric fluid, and a year ago just recently finished the acquisition of that dielectric fluid. What I wanted to show you today really is what happens, what goes on, how does a transformer get made, what does the insulation system have to do with anything, and the dielectric fluid, how does that impact the performance of the transformer. So come on inside and let's go learn about transformers.
Peak transformers are a line of transformers that can run at a higher temperature and not cause any additional degradation to the insulation system. So as a result, we can build them smaller, we can build them lighter, and we can also build them for less cost. Having the FR3 as a dielectric fluid allows us to build those smaller because it can handle higher temperatures. It's got a higher flash point, it's got a higher fire point, and it's also a fluid that draws the moisture out of the insulation system, allowing that insulation system to last longer and ultimately allowing the transformer to last longer.
So when driving the moisture out, we actually run current through the core and coil assembly that heat it up, and then the chamber pulls a vacuum on that as well, and that pulls all of the moisture possible out of the unit. When it reaches a certain vacuum level, then we turn on the dielectric fluid flow, and that's where we'll insert FR3 or mineral oil into the unit itself. Now again, the FR3, having the advantage of drawing additional moisture out of that unit, provides an additional benefit for the life of the transformer.
A large part of the development was because of the both the flash and fire point characteristics of the fluid, FR3 fluid, and also the environmental characteristics, not realizing the extent of the protection that it offers on the insulation paper. That was where the big surprise came in, the whoa, as I called it.
Sustainability is key, and with the dielectric fluid, FR3 being produced primarily from soybean oil, it's a sustainable product, it's a renewable product, and it also has essentially a zero carbon footprint.
We're going to continue to develop our knowledge. We're going to continue to develop products to help Cargill, to help Eaton's Cooper Power Systems actually lead the efforts into the future.
FR3 is based on soybean oil. So it's a renewable resource. It's biodegradable and will disappear if you have a spill on land in about 30 days. It has low ecotoxicity to aquatic animals, so in that respect it's somewhat safer. The green tint is just to identify it as a more green and friendly material. It also identifies our material for the users, the utilities and companies that put it in transformers, so they can immediately identify it as our product, FR3. The FR3 fluid is based on soybean oil, so it has a much higher flash point and fire point than a mineral oil does. A mineral oil, of which this is an example, has a flash point around 150 degrees C, whereas the FR3 has a flash point of about 360 degrees centigrade, which means that in the case of a spill or something like that, it's much harder to get the FR3 to burn. In fact, the FR3 has both FM and UL certification, is recognized as lower hazards compared to a mineral oil.
With more than 500,000 power and distribution transformers filled with FR3 fluid globally, the trend for adopting greener, more efficient transformers has a bright future for sure. That's why Cargill Industrial Specialties partners with leading transformer manufacturers like Eaton's Cooper Power Systems and their utility customers to create safer, more reliable transformer systems to meet the ever-changing demands of consumers today. But for you and I, it's as easy as flipping a switch.